Hi and welcome back to another chemistry lesson with Mr. Simons. Again, we're looking at the second question now, atomic combinations and intermolecular forces. This is from November 2018, question 2. Again, as you can see, we have Lewis structure, we have electronegativity, polarity, but this question also brings in bond length and bond energy. All right. So, hydrogen cyanide, HCN, is a very poisonous compound used in the manufacturing of plastics, mining of gold, and as a poison. 2.1, now different definition, define the term chemical bond. And if you work through the 5 that I've done, you'll get most of the definitions, so make sure you know all of them. Define the term chemical bond for 2 marks. Draw Lewis structures for HCN, H2O. 2.3, what's the shape of the HCN molecule that we draw there? 2.4, calculate the electronegativity difference of the CN bond. 2.5, what is the polarity of the HCN molecule? So we have to say if it's polar or non-polar, right? And we have questions on another page as well. So you can pause here if you want to. First answer this before you go to the next questions. The table below indicates the values of the bond length and the bond energy of different bonds in HCN. So there we have CH, bond length, 0.109 nanometers, bond energy, 413 kilojoules per mole. For CN there, 0.116 millimeters, bond energy, there 890. So 2.6. Explain why the bond energy of CN is more than the bond energy of CH, 2 marks. Explain the difference between the bond length of CH and CN. Will HCN be soluble in water? Write only yes or no. So that's another common question. And 2.9, explain your answer to question 2.8 by referring to the polarity and intermolecular forces of the compounds. Right, so as I said, you can pause and attempt to answer. All right, I'm now going to answer the questions. So 2.1, define the term chemical bond. Chemical bond is a mutual attraction between two atoms resulting from the simultaneous attraction between their nuclei and outer electrons. So number 1, mutual attraction between two atoms, 1 mark. Resulting from simultaneous attraction between the nuclei and outer electrons, 2nd mark. Right, draw the Lewis structure for HCN. So first we need to know that carbon there would be the central atom. So carbon, group 4, has 4 valence electrons. Hydrogen, group 1, has 1 valence electron. And nitrogen, group 5, has 5 valence electrons. So there carbon, one of its valence electrons combines with 1 valence electron for hydrogen. Nitrogen has 5, 1, 2, 3, 4, 5. Right, so the 3 bonds with the 3 that's left from carbon. They form a triple bond. They form a linear shape as you can see there. So 1 mark for correct amount of valence electrons. 2nd mark for correct shape. H2O, you can see. Oxygen, group 6, has 2, 4, 5, 6 valence electrons. And hydrogen has 1, so 1 from hydrogen and another 1 from hydrogen there, which then gives me a full octet around the oxygen. As you can see, that's pentangular. 2 marks for, 1 mark for correct amount of valence electrons, 2nd mark for correct shape. 2.3, what is the shape of the HCN molecule? As you can see, that is linear. It's in a straight line, so 1 mark there for linear. Alright. So as you can see, same as the previous question, we always ask definition, Lewis structure, shape. Pick up that trend, alright? Pick up the trend, you will go far. Calculate the electronegativity difference for CN bonds. So if I go to the periodic table, electronegativity of carbon 3, nitrogen 2,5. So 3 minus 2,5 would then give me 0,5, which is 1 mark. Now what is the polarity of the HCN molecule? Write only polar or non-polar. So you can see they're not equal to 0. So therefore polarity of HCN should be polar. Explain why the bond energy of CN bond is more than the bond energy of CH bond, CN and CH. Alright, so we want to know why this bond energy such a huge difference. So number one, between carbon and nitrogen, you saw there when we drew the structure, there's a triple bond. Between the carbon and the hydrogen there, single bond, right? So CN has a higher order bond or triple bond with more orbitals overlapping. So it's 3 atoms pulling on each other, where CH is a single bond. Thus, to break the triple bond would need more energy than to break a single bond. I hope that makes sense. So the triple bond pulls harder than what the single bond does, therefore I need more energy. But you need to understand this concept of order bonds. Or 2.7, explain the difference between the bond length of the CH bond and the bond length of CN bond. Right, so CN has a longer bond length than CH because the hydrogen atom there is smaller than the nitrogen atom. So if that hydrogen atom is smaller, it gets closer to the carbon than what the nitrogen can, right? So therefore CN would then have a longer bond length than CH because H atom is smaller than the nitrogen atom. I hope that makes sense to you. Alright. Will HCN be soluble in water? Write only yes or no. So in this case we say yes, but this is now based on intermolecular forces, right? Now explain the answer question 2.8 by referring to the polarity and intermolecular forces of the compound. So number one, HCN as a polar molecule with dipole-dipole forces, right? H2O is a polar molecule with hydrogen bonds, but it also has dipole-dipole forces. So dipole-dipole forces and dipole-dipole forces. If these forces are of the same order, meaning they're the same strength or same magnitude, the substances are then able to dissolve in each other. So number one mark for understanding that HCN is a polar molecule with dipole-dipole forces. H2O is a polar molecule, and the reason why it has hydrogen bonds is because it's combined with oxygen, nitrogen or fluorine, right? But it also has dipole-dipole forces, right? And then if the forces are of the same order, very important, or same magnitude, are comparable, we say the substances will dissolve. So this 3 marks is one of our favorites that we like to ask. Alright, I hope you follow, understand. God bless. Bye.